is an oxidation process because you're adding oxygen to the system. Or if you remove oxygen, then you are giving back the electrons to the substance. And in a situation like this, where oxygen is removed from the system, for example, in photosynthesis. Photosynthesis would be a case of reduction. And we're going to see that that's for different reasons also. A third area for this, electrons, oxygen and hydrogen, has to do with hydrogen. And throughout your reading, the terms oxidation, reduction are used prolifically all over, every time, but yet it doesn't tell you what is really happening. You have to know what's actually happening. Is it have to do with electrons? Does it have to do with oxygen? Does it have to do with hydrogen? Since hydrogen has only one electron, if you remove a whole hydrogen atom, then you are losing an electron. If you add a whole hydrogen, you're adding a whole electron. You're adding an electron to it, to the system. So removal of hydrogen or addition of hydrogen is also oxidation reduction in that order. So in one example, you'll see much later on where AE, where E represents the electron, with B in the equation, goes down that way. I know my hand shakes that much. You see A then ends up giving up the electrons and B accepting the electrons. So of course A is oxidized and B is reduced. Oh, and you can go back and forth as well. All right. And in this case, what is happening is the chlorine.
Professor?
Tell me.
Can you go back to slide 45, please?
Sure. That one?
Thank you, I got it. I just had to add the last note.
No problem. My pleasure. All right. In this case, then, you can see that the sodium, let's say sodium loses an electron, so it becomes positively charged, so it's a sodium ion. The sodium ion, let's call it that, right here, that's the sodium ion, because it's charged, positively charged, is lost that electron. This electron can be gained, it can be the same one that the chlorine picks up, but it doesn't have to be the same one. You can pick it up from anywhere out in the universe. Any electron floating around there, chlorine is willing to pick it up. So it doesn't have to be the one from sodium. Wherever this electron goes, who knows? But sodium can give up that electron. Chlorine ion then picks up that electron. And so what you end up getting then is this sodium chloride compound, which then crystallizes the way it was shown in the video for you some time ago. That means since this lost electron, this was oxidized and this one was reduced. You will be asked that. You will be asked something like, let's say, magnesium oxide, like that. And what can they ask you about this? There are so many questions I can ask you from this one molecule here, one compound. One, we ask you which element lost electrons, or which element gained electrons, or which element was oxidized, which one was reduced. You get it?